It's funny. The software landscape used to be so, well, aggressively compartmentalized. Like the borders between applications were just hard-coded, very visible.
Oh, totally. You launched a word processor if you want to test, a spreadsheet for tabular data,
Yeah.
a compiler for code.
Right. And you, the user, you operated as the central router, like manually moving the output of one static tool right into the input of another.
Yeah, copy pasting your life away.
Exactly. But I mean, stepping into the artificial intelligence ecosystem today, it feels like navigating this really dense, overlapping jungle.
It really does. The tools themselves are constantly mutating.
They are, and we've completely bypassed that era where, generic advice for literally any problem was just, oh, run it through an LLM.
Right, right. That broad stroke approach is just completely obsolete now.
It is, because today the space is fractured into these highly specialized architectural silos.
Yeah,
So we're looking at a market where, deploying the wrong model for a specific workflow, it isn't just inefficient anymore. It fundamentally breaks the pipeline.
it does. I mean, the initial monolithic phase of generative AI is just over.
Thank goodness.
Right, that illusion that these are all just, identical autoregressive engines wearing different brand wrappers, that's completely dissipated.
So what are we actually seeing now underneath the hood?
What we're seeing is profound architectural divergence, like the foundational training regimens, the specific reinforcement learning
The
pipelines.
structural trade-offs, right?
Exactly, the trade-offs chosen by the developers. All of that is dictating not just the performance benchmarks, but the actual mechanical approach these models take to solve problems.
Wow, okay, so two models might return the exact same factual output, but
But the computational path they travel to generate that string of tokens is radically different.
okay, let's unpack this, because our sources for this deep dive focus entirely on mapping that exact divergence.
Which is so crucial right now.
It really is. Our mission today is tearing down the big four architectures dominating the current market. So we're looking at ChatGPT from OpenAI, Gemini from Google, Claude from Anthropic, and Grok from xAI.
The heavy hitters.
The giants, yeah.
Yeah.
And the objective here is to just strip away all the consumer-facing marketing fluff, right? We want to analyze the raw mechanics.
We have to. We need to look at the underlying attention mechanisms, the data ingestion pipelines.
And how all those architectural choices manifest as distinct operational vibes. And, I know that word vibe, it might sound super unscientific.
It sounds a little casual, yeah.
Right, but the sources make this really compelling argument that what users perceive as a model's personality is actually the direct mathematical result of its alignment tuning.
Oh, absolutely.
Yeah.
If you don't map the architecture to your workflow, you get friction.
Yeah.
Pure and simple.
Yeah.
Because vibes, at least in this context, they're just the user-facing manifestation of weight distributions. And penalty functions applied during that reinforcement learning phase.
So it's math masquerading as a personality.
Exactly. We have to view these models as highly specialized engines. Look, you wouldn't use a high-torque diesel tractor engine in a Formula One chassis, right?
No, you'd crash immediately or just not go very fast.
Right. And the same logic applies to AI. You can't just drop an AI trained via deep reinforcement learning for logic tasks into a workflow that needs high nuance, unstructured creative synthesis.
The architecture has to match the deployment environment.
100%.
Okay, well, before we look at the newcomers, let's apply that lens directly to the architecture that essentially catalyzed this entire market.
We have to start with the pioneer.
ChatGPT. Now, it operates in a very specific tier today. It might not necessarily be the undisputed, singular, state-of-the-art model for every single highly niche domain anymore.
No, the competition is caught up there.
Right. But it has totally entrenched itself as the definitive enterprise Swiss Army knife.
That's the perfect way to describe it. It's the multi-tool.
It really is. And looking at its feature suite, the breadth of its capabilities is what sets its baseline. You've got it integrating low-latency advanced voice interactions.
Which is huge because it utilizes discrete audio tokens rather than just relying on, those clunky text-to-speech translators.
Exactly. It's native. And it has embedded diffusion models for image generation via DLE, and this is the big one. It utilizes sandboxed Python environments for advanced data analysis.
Yeah, that advanced data analysis feature is such a critical differentiator in enterprise environments.
Why is that? Beyond just being cool.
Well, it bypasses the inherent limitations of language models attempting to perform raw arithmetic. Because historically, LLMs are terrible at math.
Right, because they aren't actually doing math.
Exactly. Token prediction is not computation. It's just guessing the next most likely number based on text data.
So how did OpenAI solve that?
They solved it not by forcing the model to somehow be better at math, but by giving the model agency to write a Python script.
Oh, wow. So it recognizes a math problem, writes the script.
Executes that script in a secure sandbox, parses the output, and returns the result to you.
That is wild. It totally bridges the gap between, probabilistic text generation and hard deterministic computation.
It really does. It's a massive leap.
But, the sources emphasize that the real architectural paradigm shift, keeping OpenAI at the forefront, isn't even the Python sandbox or the audio tokens.
No, it's not.
It's the O series, the reasoning models. And this represents a fundamental departure from standard next token prediction.
It's a complete architectural leap.
Right. And my read on the mechanics of the O series, and correct me if I'm off here, is that OpenAI has essentially shifted massive amounts of computational power away from the pre-training phase and pushed it right into the inference phase.
Yeah, that's exactly right. They are utilizing test time compute.
Okay, so instead of just firing off a response based on the heaviest weights, the model actually pauses.
It pauses, yes. And it utilizes a variant of tree of thoughts or Monte Carlo tree search.
Which means it's actively mapping out multiple logical pathways before returning a single token to the user.
That is the core mechanism, yeah. Because traditional autoregressive models, they operate on a purely forward pass architecture.
They just plow ahead.
Right. They receive the prompt, and they begin predicting the next token sequentially. The computation per token is fixed.
So if the prompt is really hard, it doesn't matter. It spends the exact same amount of energy on the first word as it would for a simple prompt.
Exactly. If the prompt requires like a 3-step logical deduction, a standard model tries to solve all 3 steps simultaneously in its hidden states before generating that first word.
Which is why they fail at complex logic so often.
Right. But the O series completely decouples generation from reasoning.
How does that look in practice?
Well, when you issue a complex prompt, the model enters this hidden chain of thought state. It generates a potential logical step, evaluates that step using an internal reward model.
Like it's grading its own homework.
Yes. And if the value is high, it proceeds. But if it detects a logical flaw or, a dead end, it backtracks. It discards that branch entirely and explores an alternative path.
So it's essentially playing chess against itself. It's evaluating the board state of its own internal logic.
That's a great analogy.
Let's look at the deployment of this in a really hardcore developer scenario, because I think this brings it to life. Say you have this monolithic legacy application.
Oh, everyone's nightmare.
Right. And you need to write a migration script. You have to pull data from this archaic SQL database, normalize all the schemas, handle, a dozen edge case null values, and then push it all to a modern NoSQL structure.
That is a hefty prompt.
Huge. A standard model starts writing the script immediately, and it gets the SQL query right, sure, but by the time it reaches the NoSQL insertion, its context is degraded.
It totally forgot the schema mapping.
Exactly. It forgot the mapping, and the script just fails.
Yeah.
But the O series allocates that test time compute to plan the architecture first. Like it outlines the schema mapping as step 1, verifies it, outlines the error handling as step 2, verifies it.
And only then does it actually begin generating the actual syntactical code.
It's mind-blowing.
It is. And the scaling laws for this are just fascinating because historically, we've relied on scaling laws that dictated, better performance required exponentially larger pre-training data sets and massive parameter counts.
Basically just throw more data and bigger servers at it.
Right. But the O series proves that you can achieve state-of-the-art performance on highly complex reasoning benchmarks like competitive programming or advanced mathematics by scaling inference compute instead.
So the longer you allow the model to just sit there and think,
the longer it explores that latent space of potential solutions, the higher the accuracy of the final output.
Wow.
I mean, it is computationally expensive on the back end, obviously, but it virtually eliminates the hallucination problem in deterministic logic workflows.
But here's the thing. Despite this incredibly sophisticated, self-evaluating logic engine, the sources highlight a glaring paradox when it comes to the model's user-facing personality.
Oh, the personality quirk.
Yeah. I mean, If ChatGPT is executing these high-dimensional Monte Carlo tree searches to map out complex logic, why does it sound like a middle manager at a corporate retreat?
It really does. It's very rigidly corporate.
Right. It operates like an overly sanitized consultant. If you prompt it for anything outside of sterile code generation, say, generating a narrative or evaluating a subjective thesis, it exhibits this relentless compulsion to synthesize the output into a perfectly neutral, frictionless summary.
It has to balance everything.
Yes. It almost always appends this concluding paragraph that moralizes the whole topic, usually something along the lines of, in conclusion, balancing tradition and progress is key.
Always the incongruent.
Or always. It's like a brilliant but soulless straight-A student.
That specific behavioral loop, that in-conclusion phenomenon, is a direct artifact of heavy reinforcement learning from human feedback, or RLHF.
Okay, explain that. How does human feedback make it so boring?
Well, OpenAI's alignment strategy prioritizes safety, helpfulness, and absolute neutrality. So during the RLHF phase, you have these human raters, and humans consistently score polite, structured, and balanced responses higher than opinionated or stylized ones.
Because nobody wants an AI that yells at them, I guess.
Right. But when you apply those preference weights across billions of parameters, the model inevitably converges on an average sanitized tone. It suffers from a slight mode collapse of personality.
Mode collapse, that's a great term.
Yeah, the variance in its stylistic output is mathematically compressed just to ensure it never generates anything remotely offensive or unbalanced.
It's the homogenization of output,
Yeah.
which really means deploying ChatGPT is a highly specific choice.
Very specific.
Like if a server is failing at 3.0 ARM and you need flawless execution of a Python debugging script, that homogenization is a massive asset.
You absolutely don't want stylistic variance at 3.0 AM.
No, you want the highest possible probability of syntactical accuracy. You just need it to work. But if the workflow relies on manipulating human language or subtext or creative architecture, that heavy RLHF penalty becomes a severe liability.
It completely breaks the creative pipeline.
Because its inability to hold a nuanced, opinionated structure without collapsing into that corporate summary just ruins the output.
Right.
And that limitation is the exact wedge that Anthropic used to capture the developer and creator markets with Claude.
Yeah, let's talk about Claude, because Anthropic's architectural approach represents a really stark divergence from OpenAI's RLHF pipeline.
Well, Anthropic was founded by ex-OpenAI researchers, right?
Right.
Heavily focused on safety.
Yes, and they recognize the bottleneck and the behavioral flattening caused by relying entirely on human raters for alignment.
Because humans are inconsistent.
They're inconsistent, their preferences trend toward the bland and agreeable, and honestly, scaling human feedback is just incredibly slow.
So what was Anthropic's solution to that?
They introduced constitutional AI, which shifts the burden of alignment from human raters to an algorithmic rules-based structure.
Here's where it gets really interesting. To break down constitutional AI mechanically, Anthropic isn't just feeding Claude millions of thumbs up or thumbs down ratings from random contractors.
No, they instantiate a literal text-based constitution.
Right, a foundational set of rules governing behavior, logic, and structure. So during the training phase, specifically the reinforcement learning from AI feedback, or RLAIF phase, the model generates a response.
And then a secondary instance of the model evaluates that response strictly against the Constitution.
So it critiques its own output.
Exactly. It revises it to better align with the rules, and then uses that self-generated revision as the high-reward training signal.
That is brilliant. By mechanizing the alignment process, Anthropic avoids that mode collapse we see in standard RLHF.
Right, because the Constitution provides a high-dimensional structural framework for the model to operate within. It's not just hammering it toward the median of human preference.
Now, I know in earlier iterations this made Claude notoriously recalcitrant.
Oh, it was overly cautious to a fault.
Yeah, it over-indexed on safety rules and would refuse totally benign requests if it calculated even a fractional probability of violating some harmlessness mandate.
But the current tuning has really refined those weights.
Yeah.
And the result is a model that deeply understands structural rules, whether those rules govern the pacing of a 50-page manuscript or the logic flow of a React application.
And the sources emphasize how this architectural difference manifests in the model's tone, which is why writers and creatives are totally migrating to Claude.
It's remarkably different from ChatGPT.
It really is. Because Claude isn't flattened by millions of average human preference ratings, it retains this incredibly high degree of stylistic variance.
It sounds shockingly human.
It does. It's like the cultured friend who drinks loose leaf tea, you know? It doesn't use those cliche corporate wrap-ups. It processes subtext, emotional tone, nuance.
Yeah. If you feed it a dense, complex data set and ask for an analysis, it doesn't just summarize the data.
Right. It adopts an analytical framework.
It writes like a highly educated peer who actually understands the nuance of your prompt. You can upload a 50-page manuscript and it turns into a high-level editor that critiques pacing and character arcs.
Not just a spell checker.
Exactly.
But the paradox of Claude is wild. How can a model be both the most poetic, emotionally intelligent writer and the top choice for hardcore developers building interactive apps?
What's fascinating here is that it's actually not a paradox at all. Not if you view both prose and code as complex, interconnected structures.
Okay, explain that.
Well, Claude's attention mechanism and its RLAIF tuning make it exceptional at maintaining structural integrity over long contexts.
Because of that constitutional AI foundation.
Precisely. Think about it. A novel requires maintaining character arcs, thematic consistency, and pacing over tens of thousands of tokens.
Right.
A software application requires maintaining state, variable scope, and architectural logic over the exact same distance.
Oh, wow.
The underlying capability, high-fidelity structural retention, is identical.
That makes so much sense. And Anthropic totally capitalized on that structural retention by revolutionizing the developer interface with the artifacts feature.
Artifacts is a game changer.
It really is. They looked at the traditional LLM workflow for developers, which was just so painful. You prompt the model, get a massive wall of raw code, copy it, paste it into a local IDE, compile it, hunt for the syntax error.
Copy the error, paste it back into the chain.
Exactly. It's awful. And they realized the friction was entirely in the I/O layer. Artifacts bypasses that loop entirely.
It fundamentally changes the chat interface into an integrated development environment.
Right. When you prompt Claude to build an interactive dashboard, it generates the code, but it also spins up a sandboxed execution environment directly adjacent to the chat window.
Yeah, often utilizing React components and shadow DOMs.
And it renders the application in real time. It manages the state of the code in the chat and the state of the execution in the artifact window simultaneously.
Which means rapid prototyping operates at the speed of thought.
Literally. You tell Claude to build a data visualization tool. It renders the tool. You look at it and realize the color mapping is wrong, so you just type, hey, shift the heat map to a divergent color scale.
And because the model understands the structural context of the code it just wrote, it pushes the delta update to the code, and the artifact window re-renders instantly.
The model isn't just functioning as a code generator anymore. It's functioning as a real-time interactive compiler.
It's a masterclass in reducing cognitive load for the user. Claude handles the syntax and the compilation, allowing the developer to operate purely at the architectural and strategic level.
It's a massive workflow revolution.
It is a highly specialized workflow optimization. However,
There's always a however.
there is. Claude's power requires the user to bring the data into its environment. You have to manually upload the code base or paste the text or provide the context.
Right.
If your workflow involves massive, sprawling data sets distributed across an enterprise ecosystem, the friction of moving that data into Anthropic's interface becomes a serious bottleneck.
Which introduces the fundamental thesis behind Google's Gemini.
Exactly.
I mean, if ChatGPT and Claude are brilliant conversational partners, what if you don't just want a conversation? What if you need an AI that lives inside the tools you already use and can just eat mountains of raw, messy data?
Enter Google's Gemini.
Right. If OpenAI built the universal logic engine and Anthropic built the structural artisan, Google built an industrial-scale infrastructure layer.
Gemini's entire value proposition is predicated on its proximity to the data. That's its superpower. Deep integration.
Because if you live in Google Workspace, Docs, Gmail, Drive Gemini is inherently embedded.
It's native to the environment.
Yeah, the application of this is honestly kind of magical. Like, you can just casually ask Gemini to dig through 3 months of messy emails to find a specific tracking number.
And it doesn't require you to extract your data to analyze it. The model resides inside the data environment.
But the architectural engineering required to support that level of integration at Google's scale, It's staggering. The expert really needs to dive deep into what makes Gemini technically unique here.
Yeah, we have to talk about the context window. Because to make Gemini function as an ecosystem-wide processor, Google had to solve the quadratic memory bottleneck.
Right, which plagues standard transformer attention mechanisms.
Exactly. In a traditional LLM, as the context window grows, the computational cost of the attention mechanism scales quadratically.
Hmm.
Every single token must attend to every other token.
So it just blows up memory-wise.
It does. Pushing a model to a 100,000 token limit was considered a massive achievement just recently.
And then Gemini just shattered that ceiling.
Completely. Pushing the context window to 2 million tokens and theoretically far beyond.
And to put a 2 million token context window into perspective for you listening, you are not just uploading a textbook, you are uploading an entire library of documentation.
A developer can drop an entire massive enterprise repository into Gemini simultaneously.
The model doesn't even need to use retrieval augmented generation to search for relevant snippets. It holds the entire architecture in its active memory.
Yes.
But the mechanics of how Google achieved this without the memory requirements just imploding their servers, that's the interesting part. My understanding is they are utilizing advanced techniques like ring attention, right, or blockwise compute.
Precisely. Rather than forcing a single GPU to hold the entire quadratic attention matrix, techniques like ring attention distribute the sequence across a massive cluster of accelerators.
Oh, so they break it up.
Yes. The GPUs calculate blocks of attention locally and then pass the key value states in a ring topology to the next node.
Which allows the model to process sequences that are orders of magnitude larger than the physical memory of a single chip.
Yeah.
That is brilliant.
It is.
Yeah.
But the context window is really only half of the Gemini equation. The other half, and arguably the more revolutionary architectural shift, is its native multimodality.
We really need to spend time explaining the difference between stitched-together text and image models versus Google's approach.
Yeah, the distinction between stitched multimodality and native multimodality is critical here.
Because in earlier models, if you wanted the AI to process a video or an image, the system relied on discrete pipelines. Like a vision transformer or an OCR system would look at the image, extract a text-based description.
Like this is a picture of a red car.
Exactly. And then feed that text to the language model. The language model never actually saw the image. It only processed a low-fidelity text translation.
It was a severe bottleneck, heavily prone to data loss.
So what did Google do differently?
Google eliminated the translation layer entirely. Gemini was trained from the ground up on a joint embedding space.
So natively, from scratch.
Exactly. During the pre-training phase, the architecture ingested text tokens, image patches, and audio spectrograms simultaneously.
Meaning the mathematical vectors that represent a visual curve, an audio frequency, and a text token. They're all mapped into the same high-dimensional latent space.
Yes. The model natively understands that the visual waveform of a spoken word, the pixels of an object, and the text describing that object all share the same semantic representation.
Because it operates in that joint embedding space, and because it has a multi-million token context window, the practical application is just mind-bending.
It really is.
Like you can upload a raw, unedited, hour-long video file of a board meeting directly into Gemini. You don't need to provide a transcript at all.
No transcript needed.
The model processes the visual frames, correlates the body language with the raw audio waveform of the speakers, cross-references that with the text of the PDF agenda you also uploaded pre.
And synthesizes an analysis of the room's dynamic all at once.
It is ingesting reality at an industrial scale.
It is. However, this infrastructural focus explains the primary critique leveled against Gemini in our sources.
Right, because it is designed to be this omnipresent, massive-scale data processor integrated into enterprise cloud systems, its user-facing persona is incredibly sterile.
It feels like an advanced iteration of the traditional Google search algorithm, simply given a conversational voice.
It sounds like a massive industrial factory floor. I mean, it's highly efficient, brilliantly engineered, capable of moving massive tonnage, but it is not a cozy space to hang out in.
No, it's not designed for creative collaboration.
It lacks the warmth of Claude or the sharp logic focus of the O series. If you ask Gemini to help brainstorm a creative concept, the output often feels dry, highly formatted, and deeply, deeply safe.
It operates exactly like an infrastructure utility. But you don't expect your electricity grid to have a sparkling personality, right?
No, you just expect it to handle the voltage.
And Gemini handles the voltage of massive multimodal data better than anything else on the market. If you are heavily invested in Android or Google Cloud infrastructure, Gemini's sheer processing power makes it the undisputed king, regardless of its conversational warmth.
It's the ultimate expression of data gravity. The model goes where the data lives.
Yep.
But, all three of the models we've discussed so far, ChatGPT, Claude, and Gemini, they actually share a fundamental similarity in their deployment.
They're heavily curated.
Yes, they operate on static, pre-trained datasets, supplemented by strictly controlled web search tools. Their alignment protocols are designed to filter out noise, controversy, and chaos,
They are, by design, sterilized environments.
which provides the exact inverse mandate for Grok.
Ah, Grok.
Yeah.
The wild card.
We've analyzed the corporate worker, the creative intellectual, and the industrial powerhouse. Now, what happens when you build an AI specifically designed to break the rules and live in the chaotic stream of human consciousness?
You get Grok, built by Elon Musk's XAI team and integrated directly into the X platform.
Right, and it's architected to operate inside the chaos. The developers deliberately discarded the traditional alignment strategies that prioritize polite, sanitized neutrality.
Yeah, Grok's system prompts and reinforcement pipelines are tuned to be irreverent, highly sarcastic, and actively willing to engage with controversial or edgy prompts.
Prompts that OpenAI or Anthropic would immediately flag and refuse.
Oh, instantly. And that fun mode persona gets the majority of the media attention.
Right, because by altering the system prompt to instruct the model to use dark humor, slang, and a cynical tone, XAI has created a highly engaging user experience.
You can ask Grok to ruthlessly roast your codebase, or explain complex quantum physics in the persona of a 1920s gangster, and it executes the persona flawlessly.
But evaluating Grok purely on its sarcastic tone kind of ignores the underlying architectural advantage that makes it a formidable tool, doesn't it?
It completely ignores it. The real power is its real-time, low-latency integration with the X firehose.
The real-time retrieval augmented generation, or RAG, architecture of Grok is entirely unique in the market right now.
It is, because when ChatGPT or Claude needs to access real-time information, they execute a traditional web search.
Right, they ping a search engine, scrape the text of a published news article, read it, summarize it.
And that pipeline introduces massive latency. It relies on a human journalist witnessing an event, writing an article, publishing it, and the search engine indexing it.
That takes hours, sometimes days. But Grok bypasses the entire publishing pipeline entirely.
Because Grok sits on top of the X infrastructure, it has direct API-level access to the global stream of public posts.
The fire hose.
The fire hose. As an event occurs, an earthquake, a sudden market crash, a live political debate, millions of users generate raw text and video.
And Grok's architecture continuously updates its vector databases with these live embeddings.
Right. So when you query Grok about a breaking event, it instantly retrieves the most highly correlated live posts, appends those embeddings directly into its context window, and synthesizes the ground truth in real time.
Mere seconds after the event actually happens. The speed of that data ingestion is unmatched.
It is.
If you are tracking a rapidly evolving financial situation or a live cultural moment, Grok's latency is practically zero compared to a traditional model.
But this architecture introduces a massive structural vulnerability.
The catch. Because X is filled with unverified rumors and misinformation.
Exactly. When you inject the raw, unfiltered X firehose directly into the context window of an LLM, you are injecting unparalleled levels of noise.
So asking for breaking news means getting the absolute latest information mixed with unchecked chaos.
It is the ultimate test of an LLM's reasoning and filtering capabilities, because a model is only as good as the context it is provided.
Right.
If the RAG pipeline pulls in 20 highly engaged posts that are completely hallucinated or deliberately false, the model has to computationally weigh that context against its pre-trained foundational knowledge.
And often, the recency bias of the RAG system overpowers the foundational weights, right?
Yes, leading Grok to confidently synthesize and output an absolute falsehood as breaking news.
So what does this all mean? Utilizing Grok is like plugging your brain directly into a global, unedited scanner feed.
That's a very accurate way to put it.
It's like a brilliant but highly cynical news anchor screaming at you from the floor of a chaotic stock exchange. It requires you to possess incredibly strong media literacy and internal filtering capabilities.
You are trading the curated safety of Claude or ChatGPT for raw, blistering speed.
Is the speed of the information worth the noise you have to filter through? That's the question you have to answer.
And it's worth noting that the base models underlying Grok, specifically Grok 1.5 and Grok 2, they are not just lightweight wrappers.
No, the sources highlight that XAI has achieved near state-of-the-art performance on complex mathematical and coding benchmarks.
Which proves that the underlying parameter efficiency and foundational training are maturing incredibly fast.